All right. Yeah, thanks everyone for joining. I'm really excited to show y'all a couple of libraries I've been working on for the last few months that I think will just make the developer experience a little bit nicer. It's been
Yes.
really yeah, it's been really fun to work on these, and I think I'll give you an overview real quick. I'm going to be talking about two libraries, dbxray and datapotato or datapotato. And briefly what they do, dbxray will take a JDBC connection and give you a clojure map that describes a database. So that includes tables and then columns for those tables, and you'll see more in a second. And then datapotato is a way to deal with fixtures in your tests to generate data, insert the data into a database, and then also do cleanup and things like that in a way that's really concise and that avoids a lot of tedium and makes it less error prone when you're dealing with hierarchies of data. So these two libraries also work together in a kind of fun way, which I will show you about like halfway through the synergies from these two libraries and the donut universe. So starting with dbxray, I mentioned that its purpose is to take a connection and give you a clojure map describing a database. And so I'm just gonna show that real quick. Over here on the left, you can see that I have some statements creating just a few tables, users table, a to-do list table, and a to-dos table. So this is like the beginnings of your new to-do list app that's gonna unseat the incumbents and take the world by storm. And so we also here have an embedded Postgres database and a connection to that database. So that's con here over here. And so in the comments here, I have create tables, and I've actually run this already in my REPL. And finally over here, we use the X-ray function on the connection to produce the metadata. So without further ado, oops, here it is. Here's the X-ray. So the data that gets produced here, you can see it's a map, and the keys for the top level of the map are the table names. So you have users, and then down here we also have to-do lists, and then also to-dos. One thing about this map, it's an ordered map, just a small implementation detail. And the ordering of these keys is derived from the graph basically of dependencies of, for example, you have in your to-dos, you have a foreign key that references to-do lists, and then also to-do lists reference users. And so the ordering of the keys here is going to be stable using that kind of dependency tree. Digging into it a little bit, you can see that for each table, there's another map. And right now that map just has a single keyword, and that's columns. And under columns, you have your columns. So we have ID here. And then what I've tried to do with dbxray here is come up with some kind of canonical representation of a database. And so this is definitely an area where I feel like I could use some help, because I think that I'm sure that there are aspects of this that I haven't thought through well, or that I'm not really capturing a database or a column definition in a way that's ideal. But I think for the time being, it's good enough. So what you can see is there's a column type here. There's also this raw key, which for me, for right now, this is the kind of fail-safe where if dbxray isn't producing all the data that you need to in a kind of nicer format, then you can at least rely on the raw data to then do whatever it is that you need to do. So aside from the raw data, there are these other keys. There is primary key. There's also unique and auto increment. So this representation of a column, including the column type, including whether it's a primary key or it's unique or whether it's auto incrementing. These are the things I've captured so far that I think will give you more leverage in building tooling around producing code or producing visualizations of your database. And yeah, but I may very well be missing something. So one of the things that actually that I might be missing here, or that could be useful here, is for columns like varchars, where they have a limit, right? It's like varchar 50 or varchar 256 or something like that. Having a top level representation or kind of canonical representation of that, of the notion of a limit for a column, is something that could be added. Any questions here? No. Okay, cool. So the reason why I created dbxray was actually so that I could then use this kind of data to generate schemas using one of the many schema libraries out there now in Clojure land. So there's plumatic schema, there's malli, and then there's also clojure.spec. I think those are the heavy hitters. And so what you can see is that there are these generate namespaces for malli and for schema and for spec. And there's also a datapotato namespace there too, which we'll look at in a minute. So once you have an X-ray, you can use one of these functions, which are aliased in the kind of core X-ray namespace, like dbxray namespace. Down here, there's clojure.spec, malli schema, etc. These are basically aliasing these various generates functions in their respective namespaces. So when you generate a malli schema, all it does is pump out some data for you in a vector, and then you can go ahead and take that and put it into like, my app, and so you can just copy it and paste it in there and then pop it out of the vector. And then now you have a nice starting point for some schemas. So the idea here is that, these are great tools. And if you have an application that is a somewhat long-lived application, or for whatever reason, you already have a bunch of different tables in your application, it can be kind of a chore to go through and then start producing schemas for these tables, if that's what you want to do. So with dbxray, it's now, pretty easy. You have like a decent starting point, right? So in the malli schema that gets produced here, you can see it has a lot of conventions, I guess, or like assumptions of how you want to represent your schema. So for example, each column name is going to be a namespace keyword of the table name and then the column name. And then you can see here, there's this optional, there's this map of options, and then within that, there's an optional keyword. And you can see for ID, that is false. And in order to derive that value, when the malli schema is being generated, it looks at the X-ray to see, is this column nullable? And so if it's not nullable, then it is not optional. It's a lot of double negatives there. But so let's see here. Let's see here where that actually happens. So in the malli generation, for example, there's this column spec function, and it goes through and it looks at the various aspects of a column that the X-ray captures and inspects those and uses those to generate the schema. So you can see here, optional here, it looks at the nullable value for the X-ray, the column and the X-ray. And just to show you again here, if we look at users, ID, and then we go down to this, where is it? Okay, well, so actually the nullable key is not present for the column, for the ID column, which is it not being present means it's nil, it's a falsy value. And that is how the user ID here is constructed. For the predicate for the schema, it also, again, looks at the X-ray. And in this case, what it's doing is it's looking to see, is it a primary key and is it an integer? And if it is, then it uses the pos_int predicate function. That is also another area where I feel like, I wonder if this could be done better, because like this integer pk is a kind of derived column type where it looks to see like, is the captured column type an integer, and is it also a primary key? So I feel kind of iffy about that, but I mean, again, this is like, I just put this library together recently, and we'll welcome any kind of like feedback or help around how to actually capture this stuff and do it in a way that's consistent and coherent. Anyway, that being said, you can see here with this column types var here, there's a mapping of different like X-ray column types to the predicate that should be used to generate the schema for it. So you can see there's various kinds of strings. There's clobs, text, and varchars. And so when this this column spec function in here encounters one of these, it's going to like put in the correct symbol for your schema. Any questions there? Cool. All right, yeah, so basic idea is that you have some kind of lower level representation of your database in Clojure, and then you can use that to generate useful code. And this is especially easy in Clojure because, code is data, and it's very easy to just put in these symbols and have them get printed out here, and then copy those over to your actual application, and you're good to go. I'll point out here too, like with Clojure specs, it also respects whether or not a column is nullable and uses that information to do either like rec for the keys, or you could also, in this case, there are no optional keys, but you would have like opt, to-do list, description, or something like that, right? So there is like a decent amount of intelligence in how these specs are generated. All right, well, I think that's actually, I think that's actually it for dbxray. It's a nice little work in progress. I think that as it is, it's useful. I think that there are some cool possibilities for what we can do with it in the future. One of the things I'm going to talk about a little bit later in the talk is using tools like this in order to improve upon or create dev tools that can aid you while you're building an application. I know like Reveal and Portal, for example, are already existing good dev tools, and I have other ideas in mind for using this kind of information to give you an overview of your system, see how things are related, and be able to do that in a way that's more easily consumable than just like parsing through Clojure maps, and be able to have those tools, those aids with you as you're doing your work. Let's see here. So, one other thing I want to mention here is another question that I'm kind of working with is the question of what are the abstractions for generating these schemas. So right now, each of the different libraries, let's see here, Clojure. There we go. So malli, the malli generator and the clojure.spec generator, for example, they have some things in common, but generally, like basically, these two different namespaces don't really rely on any abstractions. It's just, transforming the X-ray into some other form in a way that's pretty like manual, so to speak. So I don't even know if it's important really to try to come up with some abstraction for deriving some other data from the X-ray data. Maybe it would be useful, maybe not. For the time being, it seems like it's really not important, but it's something that I'm curious about. And yeah, if anyone wants to help out with this stuff, would love thoughts there. All right. So I think that that's it for dbxray. Are there any questions before I move on to datapotato? Nope. Okay, cool. All right. Okay, so datapotato, this is actually a fork of a library I wrote a few years ago called spec monster. And so the purpose of datapotato is to handle database fixtures in your tests. And the reason why you might want to do this is because you can, when you're writing your test, you can end up with like really large unwieldy let bindings. Like, y'all may have written code that looks something like this. Let's say you have a form application, and in your form application, you want to test some scenario where a post has been liked, by 3 different people. But in order to create that scenario, you have to create 3 different users who have liked that post. You have to create this whole hierarchy of records of like a topic and that topic's category. And you also have to create the post that's being liked. And you have to keep track of all these different records and correctly wire them up so that each like, for example, belongs to a different user. And that kind of code, it's just very verbose. It's brittle. It's easy to make mistakes when you're writing that kind of code. And it's also, I think it reduces the quality of your tests in that when you're writing something like this, it can be really hard to tell what it is that you're actually trying to test, right? Because you have to create all this boilerplate. And so like, I don't know, like when I was writing this thing, I kind of kept thinking about like these different infomercials of like people trying to do basic stuff, and they just like are really failing. I don't know if y'all have seen these like infomercials for basic, trying to do basic tasks, But that's I feel like that's the situation when, or you can be in that situation when you're trying to create your fixtures for tests. So datapotato introduces a better way. And let's go ahead and have a look at that. Let's see here. So I'm going to show quickly just datapotato in action. So this scenario that we're looking at here is one where there's only users, posts, and likes. And what we want to do is we want to create a like for a post. So a like is going to belong to a post, and it's also going to belong to a user. And so what we can do is we can write code that looks like this. So we have datapotato core namespace, and we say with fixtures, and we have this function insert fixtures. And then we have this kind of query to say what kind of thing that you want to insert. And then you can then say like how many of them that you want to insert. So if we do this and we look at our mockDB, this mockDB, by the way, is an atom. So, obviously like for real tests, you'd want to insert things into possibly an actual database or like an in-memory datomic database, something like that. But for demonstration purposes, we can also insert, quote unquote, insert these records into an atom to see what gets produced. And so here you can see that the query that you write is focused on the scenario that you care about. You care about having one like. But when you inspect the database, you can see that a user was created, and then also a post was created, and then a like was created. And so this is a vector, and you can see that these are also created in the correct order, so that a user is created first, and then a post, and then a like. So this is to handle scenarios like if you are using a database which has foreign key constraints that are going to throw an exception if you are trying to reference a record that doesn't actually exist yet. You won't actually run into that scenario if you're using datapotato, because all these different records will be created in the correct order. Right. So this is just showing you like, okay, there is a nicer way of doing this kind of work that is not so verbose, it's not error prone. Another thing that I'll mention here too is that this like record that got created, you can see it has a post ID, and this post ID, this UUID is the ID for the post that you have here, right? You didn't have to wire any of that stuff up yourself manually. Datapotato keeps track of those relationships. It makes sure that that attribute values are set correctly based on those relationships. Same with created by ID over here. A like references a user, and you can see up here, this user has the ID of 645, blah, blah, blah. And you can see that that ID is set correctly down here for the like. Now, all right, so this is that's kind of like the purpose of it. It's meant to demonstrate like why you might want to use this and how it might make your life easier. I also want to talk a bit about how you actually go about starting to use datapotato in your day-to-day life. And to use datapotato, it requires a few different ingredients. So the first ingredient that requires is something to generate your data, right? So that might be malli specs, it might be clojure.spec, it might be plumatic schema, but if you're using a code base where you have these schemas that can generate data for your database tables, then you can start using those to actually you can start using those with datapotato to actually start generating and inserting your records in a way that is respects our hierarchy and wires up the IDs and all that, right? So hopefully it makes sense too, like a little bit of like why I started using dbxray, because or why I started writing dbxray, because it's like if you want to use datapotato, you have to have something set up, including these different schemas. And like with dbxray, now it's like it's easier to get to the point where you can start actually writing concise and easy to understand tests. The next thing that you need, besides some kind of schema or something to generate data, is you need what I call a potato schema. And so the potato schema here roughly mirrors what you have in your database. And in your potato schema, you can have, it's a map, and you have keys, which are entity types, which are roughly equivalent to what, like your database tables, right? And each entity types schema is going to have a few different keys. The first key is the prefix. And this prefix is used internally by datapotato to keep track of the records that are being generated. I'm not sure how much detail to go into about that, but like when you, so like over here, down here, when we're saying we want to insert a like, datapotato has to internally generate some data before it inserts that data into a database. And in order to keep track of that data internally, it uses those prefixes to uniquely name the entities or like the nodes that it's creating internally. So up here you have a prefix of U. So in datapotato's internal representation, if you have multiple users, it's going to be like U0, U1, U2, things like that. Another key that you need here for your entity schema is this generate key. And so this is where you configure something to use to actually generate data. And so here, this map has a schema key, and you're pointing to this user var up here, which is your malli schema, right? And we also have this fixtures key, and this has a table name. So this is used later. It's like when you're actually inserting data into a table, datapotato needs to know which table to insert it into. And so this is where you configure that. So the big picture here is that like datapotato has a way of taking queries like this one that we looked at down here, of where you're saying like, I want to create a single like. It has a way of taking those kinds of queries, creating an internal representation of the records that are needed to exist in your database in order for the query records that you're specifying to exist. So you're saying, like, if you're saying, I want to have a like, the requirements for a like to exist are that a post exists and that a user exists. So datapotato is going to do the work of creating those entities for you internally. Datapotato also needs a way of taking those internal, like that internal representation, and using that to then insert records into a real database. And so this fixtures key is how you're telling it how to, like one of the ways that you tell it how to do that. Sorry, I got a, okay. Sorry, I'm a little bit distracted by like the chat messages here. So Jordan's asking for a link to the datapotato repo demo.
Not now. Keep going. Not now. That was after. Keep going, Daniel. Keep going.
Okay, thanks. Yeah. Okay, I'll try to. All right. I think probably like the meetup maybe event can have it updated, or yeah. At the end I'll say something. All right. Moving forward. So we also have posts and we have likes. And so when we look at the post entity type, we can see that there's a new key here, the relations key. And what you have here is this is where you start specifying how the different entities are related to each other. If you have a post, then it's going to have a created by ID, attribute or field, and that is going to point to a user's ID, right? So this is establishing that relationship of saying like a post references a user such that the post created by ID should be equal to the user's user ID. Does that make sense? Yeah. And this relations key is how datapotato is able to wire up these different attributes correctly. So down here, when we have a like, where the post ID is the correct ID for the post, it uses this data here in order to do that wiring. And so the final piece, the final type that we have here is a like. And you can see it has two different relations. It has a post ID and it has a created by ID. And this actually has another new key here, which is the constraints key. And so there are a couple of different kinds of constraints that you can specify in your potato schema. One of them is a unique constraint. So this is saying that if I create multiple likes, that means that the created by ID should reference unique users, right? So like in a real world scenario, you want to test something, a situation where a post has gotten multiple likes. You can't have the same user liking the same post more than once, right? So by including this constraint, that's how you're able to say, when you generate multiple likes, you need to also generate multiple users. Otherwise, the default for datapotato is to generate the minimum number of records to satisfy some kind of query. So without this constraint, if you generated like 2 or 3 likes, each of those likes would have the same user, would be pointing to the same user for their created by ID. All right, any questions there? I have some visual aids here that I think that I'm gonna go through. So I mentioned that there's like a kind of internal representation of like, if you're saying, I want 2 posts. Internally, datapotato is gonna create a graph where there's these 2 posts, P1 and P0. And because posts reference users, it's also going to create a user, right? So this is the internal graph representation that datapotato builds on. Let's see here. So for the uniqueness constraint, for the scenario I just mentioned, if you did not create that unique constraint for your like, what you would end up with is if you had 3 likes, each of those likes would point to the same post and to the same user, which again is like not what we want. Instead, what we want is for each like to point to the same post, which is what's happening here. Each like L0, L1, and L2 are all pointing to P0, this post. And datapotato has generated separate users for each of the likes. So Yeah, so one of the ways I think about it is that datapotato tries to generate the world necessary to work with the data that you want to work with. And it tries to create the fewest number of records possible in order to create that world. And so these constraints are ways of modifying how that world creation happens. There's also a collect constraint. So this is like a scenario where with like datomic, for example, you can have a datomic attribute which references a datomic attribute which is a vector of references. So in that case, what you want is you still want to create maybe like multiple records. So let's say, for example, like your posts, the way that you were handling likes for a post was with a vector of user IDs that for users that have liked that post, or like a set actually of user IDs for users that have liked that post. This collect constraint is how you might handle that. I'm not going to go into detail about that because I don't want this to be overwhelming, but I do want to mention it just to say that when you're creating these different kinds of, when you're working with database fixtures, you have a bunch of different scenarios that you could be modeling. And datapotato wouldn't be a good tool if it wasn't able to handle all those different kinds of scenarios, right? If you had to sometimes use it or like partially use it, but then have to like break out of it to handle like these one-off cases, hopefully, I think the majority of the time you should be able to use datapotato to handle all your fixtures. All right, so that covers the potato schema, and then so here I'm gonna jump back to dbxray and show you, like I had mentioned that dbxray and datapotato can be used together for some sweet Clojure magic, and here we can actually see this happening. We can create a datapotato schema for your database. So I created this with the kind of recognition that if you want to use datapotato, there's like a few steps that you have to take to get things set up. But if you use dbxray, one of those steps is handled for you. You can create your potato schema. Let's see here. Oops. Yeah, you can just like pump out some code for that and you're good to go. Like so you can see here that it handles this relations key for you. It does that using your database's foreign key constraints that have been captured in the dbxray. It also generates prefixes. I think that's all it generates for you. Yeah, but it's a really good start for you. It reduces some of the tedium involved, especially if you have like a dozen or a couple dozen tables in your database that you want to start using datapotato like to generate fixtures for. So back to datapotato. Let's see here. A short, sweet example. So I have mentioned a couple of the ingredients needed to use datapotato. The first ingredient is something to generate records. So that can be malli or spec or something like that. The second ingredient is this potato schema, which its main purpose is to specify the different types of entities in your system and how they relate to each other. But it's also used to wire up datapotato to whatever record generating schemas you have, and to specify how to insert generated data, or like where to insert the generated data, right? The final ingredient that you need here is the potato DB, and I really went all out with this potato naming scheme. I have a cat named Potato. I think that heavily influenced this naming scheme. Just so you all know. But with the potato DB, you can see the three keys it has here are the schema. So that's your potato schema, which we just talked about. And there is a generate key. And for this, you can specify some generating function. So in this case, we have malli.generate, the malli.generate/generate, that function. If you're using clojure.spec, you would have some clojure.spec data generating function in here, and same with schema, right? finally here we have fixtures, and this fixtures key it does a little bit more configuration for actually inserting your data into a database. And the fixtures key also has a couple of conveniences for handling the life cycle of working with fixtures. So it has a setup key. So this will be, this can be used to like clear out your database between test runs, for example. There's also a teardown key, which I haven't used yet, but it's there. Let's see here. The way that all this stuff works together is that generally when you're using datapotato, you're going to be using this with fixtures macro. And the first argument to with fixtures is going to be this potato DB. So that's what I just covered here. And within that, you are going to call insert fixtures. And so when you call insert fixtures, this function is going to rely on the different configuration that you set up here. It's going to rely on, for example, this insert function. It's going to call that, I'm going to back up a second. It's going to rely on this, the generation configuration that you've set up to first generate records for your database. And then it's going to go through and it's going to rely on this insert function to insert each of those records in your database. It's going to rely on these table names to insert them into the correct table. And also with fixtures, it's going to call this setup function before anything else in the body of the macro gets run. So the question was, what about scenarios where datapotato can't handle your data generation needs? And I was trying to describe its design and how it's meant to be extensible and pretty flexible. So one of the ways that you could do that is in your entity type. So in order to generate data, whatever you specify at the potato DB level, you have a map here with a generator, and then you also have your entity type with a generate key and then a schema. You could instead, in your generate key for the entity type, say, specify a generator function, which is just going to take, I think it takes like a single argument, but you could have it just be like, a constant function that says like, username. So the idea here is that at each level, you can specify, you can like refine the behavior of like what datapotato does. Even actually in this query level, you could say like, I want to create a like, and then you can then go in and put this generate key in there and say, for this specific like, I'm going to specify some different generator or like some different schema, something like that. You could also, for the fixtures, you could, specify a different insert function, right? So at that level, it's meant to be very flexible. Oh shoot, I forgot to mention too, like since we're here, that flexibility is there to accommodate different databases. So even so there are helpers out of the box for XTDB, for example. And there's also a next JDBC helper and a Datomic helper. So when earlier I was saying there is like an insert function, your insert function is going to be particular to whatever kind of database you're using, right? You're not going to insert records into Datomic the same way you would like a Postgres database. And so datapotato comes with these helpers, which should help like most of the scenarios most of the time. I did want to show y'all kind of where I'm going with this stuff, which is, so I've been working on this single page app framework, which I'm actually going to talk about a little bit, Clojure. And one of the ideas I've been exploring is how to improve the dev tools, or like the dev tool experience around creating a single page app. There are like so many different pieces that are involved in creating a single page app. And so with dbxray, for example, like I just started playing with this last night, but I think it could be cool to have a kind of companion app that you can run alongside your main app to, take the X-ray data and, explore, get like an overview of your system. And you could also use datapotato, for example, to specify different scenarios. Like, so as you're doing development, you can quickly load a scenario so that you can then go in and start seeing what that looks like, interacting with your application. And all of this stuff could happen with a kind of companion single page app. So I just started this last night, but like all I've got so far is just having a back end that produces the X-ray and just a front end that is doing just a dump, like a raw dump of that X-ray data. But it's all just Clojure, and as an application, I think there's a lot of possibility here for improving that developer experience. All right, yeah, I think I wanted to have that in the in the recording, so I think I'm done.